Ever wondered how the smallest particles in the universe behave? Welcome to the intriguing realm of quantum physics, a world that is as fascinating as it is perplexing. Here, we delve into the heart of matter, exploring the behavior of particles at the most minuscule scale imaginable. Quantum physics is a cornerstone of our understanding of the universe, a key that unlocks the mysteries within atoms and subatomic particles. It differs vastly from classical physics, which can't explain the peculiar phenomena at the quantum level. In this quantum realm, particles can exist in multiple places at once, and they can even influence each other instantaneously over vast distances. It's a world that defies our everyday logic and intuition. Don't worry though, we won't get lost in a sea of technical jargon. Instead, we'll stick to the basic principles, making this complex subject a bit more digestible. Quantum physics may seem daunting, but it's all about the magic of the minuscule. Imagine a world where you can be in two places at the same time. Welcome to the quantum world, a realm where the rules of classical physics take a back seat and a new, strange reality takes over. One of the most mind-boggling concepts here is superposition. What is superposition, you might ask? Well, it's the ability of a quantum system to be in multiple states at the same time until it's observed or measured. Yes, you heard that right. Until we decide to take a peek, things in the quantum world can exist in multiple states simultaneously. It's like the universe is saying, "I'll decide when you look." This is a radical departure from our everyday understanding of reality, where things are expected to be in one place at a time. Now, let's consider the famous thought experiment by Schrödinger, involving a cat, a radioactive atom, and a vial of poison. In this experiment, the cat is both alive and dead at the same time until someone opens the box to check. This is because the cat's fate is tied to a quantum event, the decay of a radioactive atom, which is inherently uncertain and can be in a superposition of decayed and not decayed states. So, until we observe, the cat is in a superposition of being both alive and dead. It's only when we decide to peek inside the box that the superposition collapses into one of the possible states. This might sound utterly strange and counterintuitive, but that's the beauty of quantum mechanics. It challenges our notions of reality and forces us to think outside the box, pun intended. Now, if you're feeling a little dizzy with this concept, you're not alone. Even the brightest minds have grappled with the implications of superposition, but it's this very concept that powers the promising field of quantum computing, which could revolutionize our world in ways we can't even imagine yet. So, in the quantum world, things can be much more complex than they appear in our everyday life. What if I told you that two particles can communicate instantly, no matter how far apart they are? Sounds like a concept from a science fiction movie, doesn't it? But hold your breath, because this is the reality in the realm of quantum physics. This seemingly impossible phenomenon is known as quantum entanglement. When two quantum particles become entwined or entangled, they form a linked pair. They could be light years apart, yet their states are instantaneously connected. If you measure one particle, the other particle's state will instantly adjust to keep the correlation. It's as if they're communicating faster than light. Albert Einstein, the great physicist, was deeply troubled by this. He famously referred to it as spooky action at a distance. Despite his initial skepticism, quantum entanglement has been proven experimentally time and again. It's real and it's mind-boggling. So how does this work? Well, quantum entanglement arises from the superposition principle in quantum mechanics. It allows particles to be in multiple states at once until observed. When an observation is made on one of the entangled particles, it collapses into a definite state. And mysteriously, the other particle does the same, irrespective of the distance. Now, you might be wondering, what's the use of this spooky phenomenon? For starters, it has massive implications for the future of computing and communication. Quantum entanglement paves the way for quantum computers that could solve complex problems, which traditional computers would take millennia to crack. Similarly, It could lead to quantum communication networks, offering ultra-secure communication channels immune to eavesdropping. Quantum entanglement truly is a marvel of quantum physics. It exemplifies the strange and counterintuitive nature of the quantum world, challenging our understanding of the universe, and yet it holds immense potential, promising to revolutionize the future of technology. Quantum entanglement is one of the most fascinating aspects of quantum physics, pushing the boundaries of what we thought was possible. You might be wondering, what does all this quantum stuff have to do with me? Well, let's bring it all home. Quantum physics, believe it or not, plays a crucial role in our everyday lives. The smartphone you use to connect with the world, the GPS that directs you to your destination, even the MRI scans that help doctors peek inside your body. All of these technologies owe a debt to quantum physics. Here's a fun fact. The transistors in your smartphone, which are essential for its operation, are based on quantum physics. The GPS too relies on quantum mechanics to provide accurate positioning data, and MRI scans, they use quantum physics to create detailed images of the human body. So while you're thumbing through your social media feed, navigating your way to a new restaurant, or getting a health checkup, remember, you're using quantum physics. Even though quantum physics might seem far removed from our daily lives, it's closer than you think. Quantum physics is a complex field, but it's not beyond our comprehension. As we've journeyed through this fascinating realm today, we've unveiled some of its deepest mysteries. We've dived into the quantum world, where particles can exist in multiple places at once and change their state in response to observation. We've delved into the eerie phenomenon of quantum entanglement, where particles, no matter how far apart, can influence each other instantaneously. We've also explored how quantum physics isn't some far-off, abstract theory. It's a part of our everyday lives. It's the science that powers our smartphones, enables MRI scans, and promises to revolutionize our future with technologies like quantum computing. Quantum physics, with all its complexities and paradoxes, truly is an awe-inspiring field. So, the next time you use your smartphone or get an MRI scan, remember, you're experiencing the magic of quantum physics.